Hello everyone. In this video, I'm going to discuss the building a multi-threaded web server project, which is the last chapter of the Rust programming language official book. So I have an implementation of this, and yeah, this is a quick summary. Like what we do is we build a server that listens at our local host at port 8080, and we receive two HTTP requests, and then we respond based on the request. Listen for TCP connections on a socket, parse small requests, create proper response, improve the throughput of our server with thread pool. Yeah, so this is what we did in this project. I have this implementation ready, so I'm going to discuss this in this video. So let's begin. So this is my library crate. Sorry, this is my crate, and in this crate I have two main code files. Where library is where all the struct and everything is defined, which I'll be discussing, and main is where I'm actually invoking all those structs and starting the server and processing it. So yeah, let me start with the main function. So in the main function, I first create a host address, which is my local host, and then port 8080. Can't use port 80 because of administrator privileges and stuff, so I'm using port 8080. This is exactly what we're gonna do, put in our web browser to test our server. And once you do that, I'll come these to the thread-related tasks later. But the first things we need to start our server is we need to create a TCP listener. Now, TCP is the underlying protocol for HTTP. HTTP is text-based. TCP is more like byte-based. So, yeah, we attach a host address to a TCP listener. Now, what's going to happen is when this program we run it, this TCP listener will listen to port local this socket, and every streams coming to it will process the code over it. So yeah, once it's initialized, and this is where this logic actually happens. On the listener that we created, we are gonna listen on it, and the streams will keep flowing. And now what's happening here is that this is just a breakout logic that I did. This basically means that each stream is basically a different client request response stream. So basically what I'm saying is, like, if I open two tabs and then I make two requests to the same API, two requests to this IP address, then it will be two streams invoked here. If I do like three tabs and open that, then it will be three streams. So I'm currently processing only two streams, and after that it will shut down, like break out of this loop, and we'll close the execution. But yeah, why it's done, I'll discuss later. And this is basically a logic to break out of the loop. But this is what we are doing, important part. Whenever the TCP listener, what it does is it basically gives us the stream as a part of result. Result is, let's look. Yeah, result. And then we have to unwrap that in order to get the real value of the stream. Now, what this logic does is basically, now let's talk about pool before I dive deep. But overall, what I'm doing is, like, I'm also creating a thread pool. Thread pool is, what I'm doing is, like, this is for more of like multiple, like, parallel execution. So basically what I'm doing here is I created a thread pool, fixed thread pool size, like 5. And now I'm using this pool instance to execute all my requests. So basically what I'm saying is, like, if I open 5 tabs here, 5 streams will be received one by one, and then I'll just execute the I'll handle the request and send the response. But this is the entire in this method I'll discuss. But it will be done by my thread pool, so that, and this thread pool, what it's doing is, like, when I call execute on this thread pool, it will handle the request in a separate thread so that nothing is getting blocked. So what I'm trying to say is, like, all the 5 tabs will receive response simultaneously, even if one of them is taking much time. So because all of the requests of 5 different tabs are processed on different threads internally. But that's what thread pool is used. I'll dive deep into details how that's implemented. But yeah, handle connection is where all the logic is happening. If you see, I created some strings for response and, like, failed response. It can be done, like, you can also write this logic in a file and then read it, but for demo purposes, I quickly wrote it here, but let's avoid that. But basically what this is like HTTP 400 response, sorry, 200 response, which what it says is like this use HTTP 1.1. 200 means okay. I said then the response code and response field, and then we mentioned that content type is HTML, and then we give a HTML in the body, which just says that Rustacean pays hello, I'm Rustacean, I'm good one. Like this is basically a response to our API. It's a field. Sorry. Yeah, I'll explain this later. Failed response. If you see the different main differences is just the error code. That sorry, HTTP code. 400 means not found, and this is found. Now what I'm doing here in this method is, this is the main part, that for every stream, first we are initializing a buffer. What this buffer is basically a U8 512, this is a 512 bytes buffer. And basically it's what it's doing is like from the stream, we are reading the stream data into this buffer. And it's basically a byte. So it's 512 bytes buffer. So basically it will store something like this. Let's say B1, B2, B3, as many as is received. Now this has a limitation that is capping of 512 bytes. If it's a real server, this might be an issue, but in this project it's not because the request is small. But what we're doing is like the stream is where the request is coming, and what we're doing is reading and putting that into a buffer. Buffer just have an array of bytes, so which is literally copied from our stream. And then yeah, what I'm doing here is like a get and sleep. I'm creating two buffer, two byte string from a string. What I mean here is like this syntax, what it does is it will take a string and convert that into bytes and then store into this variable. Basically, this get and sleep is equals to like buffer because these only have byte information. Now what I'm doing here is like if buffer starts with get, that means that if the request that's coming has some sort of like get HTTP1, that means if it's a get request to this path, then this code will flow. If buffer starts with sleep, that means if you see the differences here, this is asking for sleep API and this is asking for home, like nothing. So if the sleep occurs, then this logic will occur. If both of these doesn't occur, then this logic will be occur. So basically this is a parsing logic of our over our HTTP API requests. So let's say, yeah, if this is what it came, then what we are doing is like first, we are converting that buffer to a string. Basically if you print right now, like you can try later looking at the Rust book, but if you print this thing right now, buffer, like by iterating over it, all it's gonna print is some random bytes. Actually, we can do that. Let me do it right here. Let's say for num in, let's say ambient print. Now look at this. Now we do need something to just quickly show you. Sorry. So let me run this code once. I want to show you guys something. Ignore the warnings. But yeah, the server is running, and then if I do reload my tab, you see that actually this shouldn't be done print. Let me just do that. Yeah. Let me delete and restart it. Now if I refresh it, then the request is received here. Oh, my bad. This is not where I should be doing it. This is where I should be changing it. What I'm trying to do is like show you the data this. Now, we try run it again. And I refresh the page. Yeah, see, this is what it's coming down to. Actually, to better look, make it look, I can do one more thing, which is add a space here. Now we stop and run our server again. So this is what the buffer looks like. This is getting like what I'm doing is like I'm just calling 8080 and then this will get invoked and this call will be invoked because this is the and then if you see the buffer values are raw like this. It's like 8 bytes and then it's just random numbers. So this has nothing. To convert this to something we can understand, use this string. And then if you see underneath request receive. Now all this value that's present in the buffer after it's converted to string, like request receive, this is what it looks like. It's a get request HTTP and this endpoint, this API, which is what exactly we are doing here. And then all other details. But yeah, this is what I wanted to show you that TCP stream is raw of bytes. And then, yeah. So we need to convert that to, let me stop it. Yeah, we need to convert that to some meaningful stuff first. But yeah, once we do that, what we are doing is that for response, for this one, we are just sending a response as bytes, and response is defined here. This is we are sending success response. For sleep API, which is like this path, we are making the current thread sleep for 5 seconds. And for any other API, we are just returning a fail response, which is 404. Now, the important part that you should see here is that we create a buffer, we read the streams data into buffer, and once we parse the buffer's value based on the buffer's value, once we parse, then what we have to do is to respond is that they use the same stream and write the response to it. And this will eventually return the response to this. So yeah, this is what, so basically what this function does is take the, like parse the value of the HTTP input and then send some response. Now this is all it does. And we are creating 2 dummy responses here. So this is all this code is doing, but I want to dive deep into the more part, which is a thread pool. But before I do that, let me show you one thing. So I run this. And then if you see, if I do sleep endpoint, then this is sleeping. And if you see here that it's taking time and it will wait for 5 seconds. And let's start that again. Oh, that happened because my size was 2. Let me run it again. Yeah. While it takes 5 seconds, this still loads as fast as it can. And now it just loads. So basically what it's doing is like, because we have thread pool, even if one of the threads sleeps for like 5 seconds, the other one is getting processed because the pool.execute creates everything on new thread. Now, this is what I want to show, the important part here, library. So this is the project structure. So in the main part, there's a thread pool. And every time a new request is coming, we are parsing that request and then invoking the thread pool object. Now, thread pool, what it does, it has like worker queues. What worker queues mean is basically, let me take a step back. We are using an MPSC channel here, multi-product single consumer channel, multi-producer single consumer channel. So what it does is like in this channel, when we initialize the MPSC channel, it gives us 2 things: a reference, not a reference, a transmitter and a receiver. Now in our project, what we are doing is like the thread pool will own the transmitter object, and every time the thread pool.execute is called, it will transmit a new message in this pool. And what we are doing is that at the time of this thread pool object is initialized, we initialize multiple worker queues. And multiple worker queues, what they'll do is like each time each worker is initialized, what that worker holds is a reference to a thread as well as a reference to the receiver. So what it does is like when each worker is initialized, it will start an infinite loop. And what it'll do is like it will acquire the lock, it will get message, and then it will do something about it, and then go again and acquire the lock. So let's say if there's this queue is empty, then one of these will acquire the lock and just keep waiting until something come up. And as soon as something come up, let's say two was the one who acquired the lock. So what we'll do is like two will get the lock, and something come up. Two will take that message, process it, take the message, and release the lock. As soon as the lock is released, these two people are waiting for that lock already, two and three. So one of those will get the lock. And as soon as like this will keep happening until the messages keep coming up. And yeah, each worker thread will keep processing and yeah, things like that. So that's what the channel is used. Now, the issue main is that MPSC channel gives us a way to just clone transmitter because it's like multiple producer and single consumer. But if we want a consumer side to like multiple threads to have the context, have the reference to have a mutable reference to a consumer. Basically, what we are like each thread here will be listening to the consumer, right? Like for a message, so they should all have a mutable reference. So in order to have that, like in Rust, you can only have a mutable reference once. So in order to avoid that, we'll initiate arc. Arc is a good way to basically whatever is covered under arc, it can be owned by multiple threads, but it will always refer to the same value and it will keep a count. So that way, all of these threads can have a receiver reference to reference mutable, and what that arc holds is a mutex. Now, the main part here is that the receiver can't be just used by all the threads at the same time. So that's why mutexes come. Basically, what we are doing is like we'll unwrap the arc, and then mutex will be there. So on the mutex, we'll ask for the lock each thread, and then that once the lock is acquired, we'll do processing. So basically, this is the main architecture, but let me dive deep into the code. So let's see, this is the thread pool structure, which is I defined here. It holds worker. Worker are actually the ones that are doing work, and a sender is just a sender message, which yeah, I'll explain later. Drop part, I'll explain later. But this is where thread pool is invoked. So whenever thread pool is created, we'll pass the thread pool size, like you see here. Thread pool size. You can define it. And then what we're doing is we're creating a workers with capacity of size, that size too. Basically, what these workers are like, each worker has a thread, so we'll never need more than the size. And then this is where we initiate a channel, and then this channel will give us a receiver and sender reference. Now, this is what we are doing. We are casting receiver again, as we are putting the receiver in arc and mutex. Now, we can share this to multiple workers. So what we're doing is like once the receiver is given, we will clone that receiver and push that to each worker. Now I'll show the new again, but basically what it's doing is like all the workers in this will have a reference to this. Like they'll have each a new arc, but they will all be pointing to this mutex, the same one, exact same one. And Rust, yeah, that's the way to do it basically, because you cannot have mutable reference to two mutable reference, only one can be present, but behind arc you can do that. Now, yeah, thread pool is initialized here. Now, this is execute function. So if you see here, what we are doing is in the execute function, we are sending a what's the thing called? A lambda function, let's say, a closure in Rust term, a closure, which is a function. Now, to make it work, we are doing this templating on f, and this f function should be implementing these. So this is just a syntax. You can dive deep more. This is dive deep into closure, but to make this thing work, we are passing a function f, which is a closure. And this is the syntax of saying that the closure that we are passing should have these traits implemented on it, or else this is not going to work. And for the closure that we have defined here, which is this one, it's implemented. And once that is done, what we just do is like we create a new box, and then using the sender, we send a message that new job is here. Basically, when this sender.send message new job is done, a new message is pushed in right here, and all these are listening. So that's a quick of thread pool. Now let's see what worker does. What worker does is it has an ID. So you see here we created workers worker new ID, which is a random number, and receiver.clone. Now, a worker, if you see, it also takes the receiver as an arc. And what it does is, this is the most important part. Each worker's new method, it will create a thread. And thread will create an infinite loop, which starts and end here. Now, what the infinite loop is doing, like it's reading a message. So this is the receiver that's passed to the worker. First, it tries to like get a lock on it. If, if the lock is acquired, then only receive is so this part receiver.lock is happening on the mutex. Once it's done, this part is done, and then this change starts. Then receiver comes in. The receivers dot this is the blocking function. If you acquire the lock, that means no other thread will be acquiring. Every thread will be blocked here, and like every thread will be blocked here at this execution. But if this thread acquire the lock, we will be blocked here to receive a new response in the receiver. And as soon as it's received, what we'll say is like worker got a message executing ID. And then the message can be of two types, either new job or terminate. We'll explain when terminate come, but basically new job is you saw here. That whenever sender push a message with new job and job, what it'll do is just take the job out and execute that job. And in this case, the job is this function. So it will be executed in this thread. And if you see if message is about terminating, we'll break out of this loop and this thread execution will be complete. So, and then we initiate the worker with ID, random ID, and then some thread. So basically, if you see look at it, all this new function does is that initialize the thread and put that thread in the worker object so that we can reuse it later. Now, this is just a type that it's a shortcut. And this is the message that we are actually passing in this channel. So this message is created and passed from thread pool to this, and then each worker pulls and do something. Now, yeah, that's basically it. Now, drop is basically whenever it's for cleaning of the code. Basically, what I'm trying to say is like every time we initialize, let's say we initialize thread pool of 5 threads. Now, and let's say our server only take, let me say, 5 requests. After fifth request is done, sixth request comes, we want to shut down. So as soon as it gets break, this will break off this stream loop, and this main method will go out of scope. And when it will go out of scope, this is the object created for thread pool. So drop will be called. It's just like destructor of C++. And what this drop will do is like, it will go through each workers, and then it will send a terminate command. It will not go through each worker. It will just iterate towards. Basically, if there are 5 workers, then it will send 5 terminate commands in the channel, like terminate, 5 terminate. And what? Let's say there are three threads. Then yeah, we need 3 terminate methods for each thread. So what it happens is like first thread will pull up the terminate message and then execute the logic for it, and then it will just stop, and all the threads will do the same thing. And once the threads are terminated, then what we need to do is like do this method. This is actually the part where the threads are closed, threads are joined. And yeah, basically what we did is like we had to close the infinite loop in each thread, which is this one, infinite loop. If we want to go out of that, we want to first this terminate message is received, we break out of it, and then we also need to join. So first we need to send this message for each thread, and then we need to join, and then this is the safe cleaning. If we don't do this, then what's going to happen is when we turn down, these threads will be leaked basically. Like in this case, operating system will take care of it, but yeah, this is a graceful shutdown method, which is also implemented in this book. So you can go ahead and read it. But yeah, let me give you a demo now. So what this will do is I will create a server and I can invoke it using this. It will only process 5 requests. At 6 requests, it will be, yeah, let me print this. Actually, this is not good. Let me just do request received. Yeah. So I'm initializing a 5 request thread, and I'm not gonna process more than 5 requests. So let's run this. Now, so this is 0080. Now see, connection established, worker 0 got a message. Now, if you look at it, what happened is like request came here, this handle connection was invoked in that, and then what execute is doing is just basically sending this to the channel, and then worker 0 got a message. If you see, worker thread 0 was waiting and it got a message and it executed. Now, if we do another one, worker 1 got a message. Basically, worker 1 was waiting on it and it got a message. Now, let's do another one. Worker 3 got a message now because it was waiting. Another one. 4 got a message. Now, if I do a sleep one, worker 2 got a message, but it will wait until it's processed completely. Now, if I send some random path, look about this later, but what happened is like as soon as a 6 request was sent, it broke out the loop, and as soon as it broke out the main function, cleanup initiated and the drop method was invoked. And what drop does is see, sending termination command for all threads. Sending termination command for all threads. Now shutting down worker. Now this is an interesting point, I'll explain. So what happens is like this drop was called. Now we are pushing terminate method in the queue. Let's say 5 workers were there, so we put 5 terminate methods in this queue. Now these workers will start pulling up. But think about it. All we are doing here is pushing the message in the channel and then moving forward here. So what's happening here is like we push all the channel, push all the message terminates here, but not all of them are picked up here. So basically these threads are still executing the while loop, the for loop infinitely. So what happens is like that's why this line was invoked first, shutting down thread. So what happened is like termination command was sent. This happened, but then we had to wait at thread 0 because thread 0 at this point was still running the infinite loop. Thread 0 did not, this loop, thread 0 did not pick up that yet. So we wait here to complete that thread because now it can be 1, 2, whatever it can be, but yeah, it just had to be the 0, 1. Actually, it will be 0, 1 because we created the 0 ID and put it as the 0 of the workers. But yeah. So thread 0 did not get it. Basically, we pushed 5 messages here and just started next path. But our thread did not actually complete it. They're still running infinite loop. So we'll wait there. And as soon as that was done, as soon as thread 0 was done, we started moving forward. But this log was only happened because this was done much faster. And then because thread 0 was still not completed, we had to pause here for this to complete. But yeah, so thread 0 was done. And if you see, slowing down. Yeah, this is what happened. Working 1 got a message, executing. And then worker was told to terminate. 1 was 3, 4, 0. And if you see, 0 was right here. So that's why we had to wait here. And then once all is done, these were the messages picked up by terminate 1 and then still not working for thread 0. Yeah. So basically what happened is like this was executed, this was logged, and then this waited until the thread 0 was complete. And during that time, all these workers got the messages and printed their values. And when 0 got a message, 0 was told to terminate, it moved forward, and then shutting down worker thread for 1 came. 2, 3, 4. Yeah, I hope it makes sense. I'll explain one more time. Put all the terminate messages, come here, print this, but the thread 0 thread is still not received the terminate message, so it has to wait until all other it has to wait until 0 thread finishes. So before that happens, all other received the message and was told to terminate, and then 0 got a message executing, 0 was terminated, and then 1, 2, 3, 4 was done. And then each of them was stopped, which was here. And we did good. Now, I want to show you one more thing quickly. Now, if you see, this is sleep. It's still getting processed. All the other methods will still get processed, even though this is waiting. And if you do this, it's an error. But if you do this is good. Actually, the connection was closed, I guess. Yeah. Yeah, but this is how it works. And let me know if you have any concerns and comments. I would highly recommend just go through this diagram and this book. This is a really good example of multi-threading. And this is actually how the real life scenario works under the hood in the frameworks, where TCP is raw bytes converted to strings, then those strings process the HTTP requests, and then based on the request parameters, we do something and then push the data back in the stream, and then the TCP handles responding to the client. But yeah, thank you everyone.